the proof of convergence of Nesterov accelerated gradient descent algorithm is a bit complicated. So I'll first introduce two very important ingredients for this proof, and then complete the proof using the two ingredients. And then I'll provide detailed proof for each ingredient. Okay. To this aim, I'll first introduce quadratic approximation. So this will give you kind of potential function for analyzing the convergence. So let's say the pi 0 is equal to fx0 plus alpha over 2 times x minus x0 norm square. So what does this mean? So it's centered at x0, and starting from fx0, the real function value, and then approximate real fx function using quadratic function, of which curvature defined with alpha. Okay, so this is very simple quadratic function. This is a bias term. Bias comes from the real function value f0, and then centered at x0 and increase with speed of alpha over 2 with curvature of alpha. And then we recursively define pi s plus 1. Pi s plus 1 defined from pi s and the linear approximation of point at xs. Okay, so this is kind of linear combination between the pi s and the tangent line function at point xs. And plus, since we know the f function is alpha strongly convex, we approximate the location when you have real function f. When you know the reference location xs, you can approximate this function f using the tangent function plus alpha over 2 times x minus xs norm square. That basically lower bounding the original function f. Why? F is alpha strongly convex because, okay? And then we simply interpolate the pi s potential function and the new approximate at point xs with the reference point xs. Right. So every time pi s plus 1x for all s is a fine function plus alpha over 2 times x minus vt norm square with some vt. We can very easily compute the vt, by the way. So now I will introduce two very important properties of the potential function pi. The pi t x minus fx is always lower bounded by, upper bounded by, 1 minus 1 over square root kappa per 2t times pi 0 minus fx0. Okay. From the definition of pi sx, we know that pi s plus 1x minus fx is equal to this. I just rewrite the pi s plus 1x from the definition of pi s plus 1x. Okay, and then from the alpha strongly convexity of function f, we know that this term is negative. So we have pi s plus 1x minus fx is less than or equal to 1 minus 1 over square root kappa times pi sx minus fx. So when you iteratively decrease the value s, then we have fact 1. The second fact for the pi function is this. Fys always less than or equal to the minimum value of pi sx. This is a little bit tricky to show, so I will provide a detailed proof from the next slide. Okay, so when you have fact 1 and fact 2, from the two facts, we can conclude the convergence speed. Fyt minus fx star is less than or equal to pi t x star minus fx star. Why? From the fact 2. And from fact 1, we have 1 minus 1 over square root kappa power to t times pi 0 x star minus fx star. And from the definition of pi 0 x star, we have this. It comes from the definition of pi x0. Right? And so we have this. This comes from the beta smoothness of function f. Okay? We can show fact 2 by induction. Since y0 is equal to x0 and we have f at y0 is equal to mean of pi 0x from the definition of pi 0x and y0 and x0, we know this is true. Fact 2 is true for the case s equal to 0. And so now we assume that fs is less than or equal to pi star s. From now, I will denote by pi star s, the minimum value of pi sx. Then we just need to show, it is sufficient to show that fys plus 1 is less than or equal to pi s plus 1 star. Under the assumption fys is less than or equal to pi s star. Okay, so from the gradient descent part, from the definition of ys plus 1, we first know this, because f is beta smooth. When we have beta smooth function, 1 over beta step size guarantee this. And I just rewrite this term using kappa thing, 1 over square root kappa. So this is just simply add and subtract same terms. Okay, for instance, here I add 1 minus 1 over square root kfy here and then subtract the same amount here. And here I subtract 1 over square root kappa fxs and then add 1 over square root kappa fxs. So I just add and subtract the same terms. And from the definition of pi sx star and the assumption of fys is always less than or equal to minimum of pi sx, we can simply upper bound this by this. Okay, so we have fys plus 1 is less than or equal to 1 minus 1 over square root kappa times pi s star plus 1 minus 1 over square root kappa gradient of fx s transpose xs minus ys plus 1 over square root kappa fx minus 1 over 2 beta gradient of fx s num square. By the way, this term comes from the convexity of function f. When function f is convex function, this is upper bounded by this. Okay. So we need to show this to conclude the proof of fact 2. Okay, on the assumption fys less than or equal to pi s star, we can conclude fys plus 1 is less than or equal to pi s plus 1 star after we showing this inequality. Okay. So since we know that the potential function pi is always a affine function plus alpha over 2 times x minus vs norm square, the Hessian of pi sx always equal to alpha times identity matrix. So there exists vs function pi s plus alpha over 2 times x minus vs norm square. Okay, so here this vs and this vs is not the same, so I will use different notation here. Okay, sorry for confusing notations. But from now I will use vs notation to denote the minimum point of function pi s. Okay, one can easily show that vs plus 1 is equal to this. Okay, from the definition of vs and pi s plus 1. This is very trivial. Okay, so this is the detailed proof. So from definition of pi s plus 1, we can write down pi s plus 1 xs is equal to pi s plus 1 star plus alpha over 2 times xs minus vs plus 1 norm square. And this is equal to 1 minus 1 over square root kappa times pi s xs plus 1 over square root kappa f xs. This is because this part pi s plus 1 xs from the definition of pi ss is equal to 1 minus 1 over square root kappa times pi s xs plus 1 over square root kappa. What is the definition of pi xs plus 1? F xs plus gradient of f xs transpose xs minus xs, so this will be 0 plus alpha over 2 x minus x s norm square, because the pi s plus 1 xs is equal to the linear interpolation between pi s xs and alpha strongly convex approximation at point xs. But since the reference point is xs, this approximation is just equal to fxs. So we have this. And from the definition of pi s xs using this form, so this is equal to pi s star plus alpha over 2 times 1 minus 1 over square root kappa times xs minus vs norm square. Okay, So by putting xs minus vs plus 1 on the square in the previous slide into the above equation, we have this. Xs plus 1 star is equal to this. Okay. So how to obtain this? Replace, so remove this term and then replace this term by the results in the previous slide here. Okay. Right. So we can conclude this proof by showing Vs minus Xs is equal to square root kappa Xs minus Ys. And again, by mathematical induction, we can show this term. So when we show this, basically we can simply replace this one. We can simply replace this one by Vs minus Xs. No, Xs minus Ys. And we can replace this term as well. Since this is always positive, we finally have pi s plus 1 star is less than or equal to this term plus 1 minus 1 over square root kappa gradient of xs transpose xs minus ys. So this is essentially this. Okay, so we can show fact 2. Okay, so by mathematical induction, we can show this Vs minus Xs equal to square root of kappa times Xs minus Ys. We can easily compute x0 equal to y0 equal to v0 from the definition. And when we assume Vs minus Xs is equal to this, then from the definition of Vs plus 1, we can easily check this inequality. So nothing difficult here. You just need to think kappa is equal to beta over alpha. Everything is just trivial. But this is the most important equality. To obtain this equality, we finally use xt plus 1 is equal to 1 plus square root 2 kappa minus 1 over square root 2 kappa plus 1 yd plus 1 minus square root 2 kappa minus 1 over square root 2 kappa plus 1 yt, the definition of Nesterov accelerated gradient descent approach. Okay, so basically here we replace ys by you bring this term to here and normalize by this, and then put the ys value to here, then you finally get the final inequality. Okay, so essentially to obtain Vs plus 1 minus xst equal to square root 2 kappa xs plus 1 minus ys plus 1, indeed we set the mu value, the Nesterov accelerate constant, to be square root 2 kappa minus 1 over square root 2 kappa plus 1. Okay.